All right, so last unit, I gave you a polynomial equation and you found the zeros. Remember how you had that whole big equation and then you did synthetic division, you whittled it down, and then you found all the zeros? We're gonna do that backwards. I'm gonna give you the zeros, you're gonna write the equation. By the way, this is how I make up your test problems. I figure out what I want the answers to be and then I multiply it all back together, and that's the question that I give you. We need to real quick off to the side here, review what I is, because we're gonna have imaginary zeros here. What is I? It's what for -1? Good, square root of -1. It's how we get a negative under the square root. What I want us to do is square both sides of that. And I know the colors don't show up real great on here, but if you square both sides of that, you would get I squared equals, and then here's the whole point. What happens over here? Yeah, like it's just -1. Maybe draw some hearts or stars or something next to that, because that's important and you need to know that. Do you remember that from Algebra 2? You do cover that. Don't you keep going though? Don't you do the I to the third of the fourth and then it's a pattern? Do you do the negative sandwich? That's how I taught it. Okay. We're not going to go any further. You just need to know this one. I squared is -1. Good. We remember something from last year. Good job. Okay. So you really just need to know that. Only other thing I need to say before we jump into doing these problems is if your zeros are irrational means that there's a square root in them. That's what that means. Okay. Or complex, that means that there's something imaginary in it. They happen in conjugate pairs. And that's where you have a plus and a minus. Whenever you have the quadratic formula, there's a plus minus in there. Whenever you complete the square, you get a plus minus. Okay, that's where that comes from. So for example, just shout out some numbers and I'll make an example. Right. All right, I heard 2 and 3. If you have 2 plus square root of 3, you are also going to have 2 minus square root of 3. Whether the problem says so or not, you need to know and understand that it is there. They happen in conjugate pairs. So one is plus, those are conjugate pairs, okay? Let's do another one that has an I in it. Just shout out some more numbers to me. 4. All right, let's do 4 plus 7i, perfect. What would be the conjugate pair for that? That is literally it, 4 minus 7i. It's because you get the plus and the minus in there. So if you have irrational, which means there's a square root, or complex, which means there's an I, they're going to happen in pairs. Whether the problem says so or not, you need to know it's there. All right, here's my pep talk for these. These are already looking tired. These problems are not difficult, but they are tedious. They are a little bit of writing, okay? Some people kind of like that because it's sort of like, oh, I can just multiply numbers together. Like I can just get through that, but you can't be scared of writing because they do involve some steps. Now we're writing an equation, so you should put f of x equals. If you don't want to write that on every single line, I'm okay with that, but you have to put it in the answer or it will take off because it says to write a equation. So you need an f of x equals, you need an equal sign for an equation. I'm going to write it on every line because I'm the teacher and I'm trying to show it to you, but as long as you put it in the answer, right? Now, if x equals 0 is one of your answers, what has to go in the equation? Good. And what would be x plus 0 or x minus 0? It would just be x. You can write plus 0 if you want, but that's like, no, I wasn't going to say that. Jeez. You don't need it there. All right. Now, if x equals 6 is one of your answers, what's going to go in the problem? Good. X minus 6. And then for the -2, it'll be x plus 2. Then you have the job of multiplying that all together. But you guys have been good at distributing. And if you can multiply numbers together, you're going to be just fine. Here's the only thing, though. You can't do all 3 of them at once. You can only do 2 at a time. So this x is going to wait patiently. And we're going to multiply the other 2 together. It's FOIL. First, outside, inside, last. Here we go. X times x. Good. Perfect. Now, the outsides give you 2x. The insides give you minus 6x. You want to try to do those together to save yourself some writing. So 2x minus 6x. Good. -4x. And then -6 times 2 is -12. Again, if you can multiply numbers, you're going to be just fine. And I believe that I believe in you. You can do it. And then what would your last step be? Yeah, distribute the x. It'll be x to the third minus 4x squared minus 12x. Here's a way you can check your work. What's the degree here? 3. Did we have 3 answers? This is how I made your test. I decided what I wanted the answers to be, and then I multiplied it all back together, and then this is what I put on your test. Do you get what I'm saying? You're just doing the exact same process backwards. Let's try another one. I know, it's wild, right? F of x equals. Now, for -1/2, you would want to have x plus 1/2. Here's the thing. Who wants there to be a fraction in the problem? Oh, right, nobody? What can you multiply by to cancel out a 1/2? 2. So if I multiply a 2 through that, what would that give us? Because that's what we would want to actually put here.
2x.
Good, perfect. So put 2x plus 1 instead of x plus 1/2. You can put x plus 1/2, and that is totally valid, but you're not going to like your life in a few seconds because it's going to get super messy. That's hilarious. She couldn't give like an actual official form. All right. And then this one says x equals 3. So what would the factor be for 3? The x minus 3. All right, but look, it says with the multiplicity of 2. So it would be x minus 3 squared. But you should just go ahead and write it again because we're going to have to multiply it all together. And again, it's not hard. It's just a bit tedious. But I believe in you. If you stay calm and organized and you're not a giver-upper, because what I get happens on these is people are like, oh, it's too much work. I'm just not going to do it. That will get you no points. Okay, you have to be like a hard worker. This is my pep talk for us. Again, you can only do 2 of them at a time. So leave the first one alone. Just the first one's always going to have to wait its turn. Okay, and we're going to multiply these together. X squared. Now you would get minus 3x and minus 3x. Those don't cancel. Good. It'll be minus 6x. And then -3 times -3 will be plus 9. Now, this one's a little bit tougher because this has 2 terms and this has 3 terms. You just need to stay organized. Here's what you're going to do. Take the 2x, distribute it through there. So we're going to distribute that to everybody. Then you're going to take the 1 and distribute it through there. You following me on this? Okay. So if you take 2x and distribute it through there, that's going to be 2x cubed minus what? 12x squared plus 18x. Perfect. And then you're going to take the 1 and distribute it. Now, the nice thing about 1 is if you distribute a 1, like nothing's going to change. So it'll just be x squared minus 6x plus 9. All right, and then your last step here is to put the like terms together, which I don't think there's too many, but you want to shorten this. So what's going to go together? Yeah, so negative 12x squared and plus x squared, that'll be negative 11x squared. And then the 18x minus 6x, what is that, 12x, and then plus 9. So you see, it's not hard. You just have to like stay organized. Of course. All right, so looking on to number 3, f of x equals, this isn't bad, right? You just have to actually do the problems. So for 4, you would have, x minus 4. Now look at square root of 7. That's irrational. So you're going to get x minus square root of 7, but you're also going to get what? Even though it doesn't say it in the problem, you have to know that it's there. X plus square root of 7. And before there's any panicking about that, it's actually not that bad because the plus and the minus are going to, okay. So again, we have 3 of these. Oh, so that means we should end up with an x to the 3rd in our answer. Just like make sure you're aware of that. The first one's going to have to just wait its turn. And watch what happens when you put these together. Because sometimes like the nastiest looking ones actually turn out the best. X times x will be x squared. Watch me points to this. The outsides will give you a plus square root of 7x. The insides will give you a minus square root of 7x. So those, they're gone. Just don't even write. You can write them, I guess, if you want, but I wouldn't. You just have to multiply the lasts. Now, a positive times a negative is going to be a negative. $1,000,000 question here. I want to see if you guys know this one. Square root of 7 times square root of 7. It'd be square root of 49, which is 7. The roots just cancel out. Bam, they're gone. And then you're just going to FOIL those together. It's first, outside, inside, last. So let's see. X times x squared, x cubed. Now, I sometimes do the insides first. Is anyone else like, it must go in descending order? Like, is anyone really type A like that? I kind of am. Like, I have to make it go in descending order. It doesn't matter. It would be the same answer either way. But the insides would give you minus 4x squared. The outsides would give you minus 7x. And then negative 4 times negative 7 will be 28. All right, so let's see. What would we put for x equals negative 6? Yeah, x plus 6. And then this one's irrational. So now I'm going to have 2 of these. It would be x. Yeah, good. And it doesn't matter what order you put those in. They're going to cancel out anyway. So the x plus 6 will just hold on. This will give you x squared minus 2. Perfect. A negative times a positive is a negative, so it'll be minus. And then these roots cancel out. You just get 2. And then multiplying that together, it'll be x to the third plus 6x squared minus 2x minus 12. How did that go? Thumbs up, thumbs down, thumbs sideways? All right, now I'm going to start putting some imaginary ones in here for you. All right, so x equals negative 1. That would be x plus 1. Oh, x equals negative 1 with a multiplicity of 2. So actually, I would need to have x plus 1 twice. You can write squared if you want, but I recommend against it because you're just going to have to write it out anyway. All right, then we've got 3i. It's going to happen in conjugate pairs, the irrational and the imaginary ones. So you're going to have x minus 3i and x plus 3i. Real quick question. Do you see how there are 4 factors here? You should have an x to the 4th in your answer. If you don't, you have done goofed, okay? You should have an x to the 4th somewhere in your answer. So here's what I do when there's 4. You can only do 2 at a time. So I would multiply these 2 together and then multiply these 2 together. When you have 3, like you can only do 2 at a time. So one of them has to kind of like wait patiently. But when you have 4, I would do 2 of them together. So let's do these 2. That would give you x squared plus what? Oh, why is it 2x? Because that's correct. Yeah, the outsides are 1x, insides are 1x. So 2x, and then 1 times 1 is 1. Here, some stuff is going to cancel. X times x is x squared. Watch. The outsides would give you plus 3ix. The insides would give you minus 3ix. Do you get how they're gone? Bye-bye. Okay. Now we're just going to multiply the lasts. Again, watch. Negative times a positive is going to be a negative. I usually just write this off to the side. 3 times 3 is 9. And I times I is I squared, which we said at the beginning. This is why I brought this up. I squared is negative 1. So if you have negative 9 times negative 1, it's just positive. I heard some of you like talking through it before I could even get there. Nice job. And if you were like, hey, I didn't quite get that, I'm going to do another one like that. So just hold on. And then you would multiply all this together. I told you it was tedious. Now, what I do whenever there's a 3, like a trinomial and then a binomial, is I would take this x squared, distribute it to everybody, then take the 9, distribute it to everybody. It really doesn't matter as long as you multiply. As long as all the terms like get multiplied together, it doesn't matter really. But that's just how my brain does it. So I would have x to the 4th plus 2x cubed plus x squared. And then I would distribute the 9. Again, if you wanted to do it differently, it doesn't matter. We're going to end up with the same answer at the end. So if we distribute 9, that's 9x squared plus 18x plus 9. You end up with this big, long statement. You should end up with something with 6 terms in it. Why should you get 6 terms? Like you should have 6 things all added up. Because this one has 3 and 2. 3 times 2 is 6. Anyway, what's going to go together there? I guess not much, huh? Yeah, good. So that'll be 10x squared. So actually, this is basically just a lot of recopying. Sorry about that. And I'm sort of not. It's not hard. You just need to not do a copy error. I'll give you a break soon. We're just going to try a couple more. It is a drill and practice thing. You have to just practice a bunch of them, right? So f of x equals, oh my gosh, there's a square root of 3. I'm going to have 2 of these. What are they going to be? X plus root of 3, x minus root of 3. It doesn't matter what order you write them in. They're going to cancel out anyway. And then the 4i will be the same thing. You just can't be scared of doing some writing. I believe in you. You're going to be fine. You just have to be willing to write it. Now, whenever there's 4, again, my recommendation is multiply these 2 and multiply these 2. And again, sometimes the nastiest ones end up being the easiest because stuff's going to cancel here. I'm going to ask you guys, when we multiply these first 2, what do we get? X squared, good. Minus 3, that's it. See how it like kind of went away? Good, it's nice. All right, and then this one will be x squared. And I always write this off to the side. Positive times negative will be negative. It's always going to be negative. 4 times 4 is 16. I times I is I squared. But I squared is -1. So this will actually be plus 16. And then we're going to multiply those together. I know you're super excited. It'll be x to the 4th. Good. Now we can do the outsides and insides together here because they're both going to be squares. This will be plus 16x squared. And this will be minus 3x squared. So that'll be 13x squared. And then -3 times 16, be -48. You know the one on your test? Don't write this, but I'll just put it on. You know the one on your test that looked like this? We went over it. This. And then you had to factor it. We just did that backwards. Like when I made that problem, I figured out what I wanted the answers to be, and then I just put it all together. All right, we'll do one more, and then I'll give you a break. This one, they're all imaginary. Yay! That's the correct response. Whenever you read a problem and you actually know what to do, that is a yay, right? Even though this is a little tedious, it's not hard, so you know what to do. You're going to have x plus 7i. What else? Minus 7i. What else? X plus 2i. Anytime you read a problem and you know exactly how to start, that's a good thing. Even if it's like you have to write a little bit, that's a good thing, okay? We're going to do the first 2 and then do the second 2. So this will be x squared. Ooh, what is it? Plus 49, good. And then this one will be x squared plus 4. And then you just put all those together. So it'll be x to the 4th. Outsides give you 4x squared. Insides give you 49x squared. So what is that, 53? X squared. And then 49 times 4. I would do 50 times 4 and then just like adjust it. Because what 50 times 4 would be 200, right? So 196. Did I do that right in my head? Good. Okay. So hey guys, look at this one. It says x equals 2. So what would be the factor for 2? It'll be x minus 2 with a multiplicity of 5. So that means 2 to the 5th power. That means you would have x minus 2, x minus 2, x minus 2, x minus 2, x minus 2. Now, I did some pep talking like, hey, this is tedious, but you can get through it. But that's kind of like, I'm seeing the faces that you make. We don't want to do that, right? So flip over the paper. I'm going to teach you how to do that with a shortcut way. I know, super exciting, right? So this is called the binomial theorem. It works if you have a binomial to a power. Okay, like, do you understand? Bi means 2, like bicycle. Do you get what I'm saying? Like, if you have a binomial like x minus 2 or x plus 2 to a power, that's what you use this for. It comes from Pascal's triangle. I'm going to write out the first couple lines of the triangle and see if this, like, you're going to need to write out the first few lines of this. It would go on infinitely.
So do I write that?
Yeah, you're gonna need to. So like, what would the next line be?
Um,
1,
3, 4. Oh, I get it. What is going on?
Hold on, I want you guys to figure it out. Just be quiet and let everybody think.
Wait, 3 times 3 equals 6. Right, so you just like.
Uh-huh. Okay, so what's the next one? 1, 5.
5.
Oh, who said it over here? 10, 10, 5, 1.
Wait, how? Oh, so you got 1, 6, 12. How'd you get 5? Whoa. Huh?
How are you getting the numbers?
You're going up.
You're adding what's above it. So look, watch, I'm going to point to it. Do you see how 1 plus 3 would give you 4? 3 plus 3 would give you 6. You're adding the 2 above. So your 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. So let's write out, we'll do 2 more lines. I don't like to do too many of these, but the next one would be 1, 6, 15, 20, 15, 6, 1. And then we'll do one more. I'm not going to ever make you go this far with it, but the last one, well, not the last one. You get that this would go on forever and ever and ever, never, never. Okay. 1, 7. What would that be? 21, 35, 35, 21, 7. So what are some things that we notice? Like every other line, what do you notice about every other line?
Yeah.
Like, do you see how this one has like that 6 that's central, but like in the next one, there's 2 10s? Yeah, so it's kind of like an even number of terms, odd number of terms. Are we following that? And they always start with 1. Okay. This first line is not actually called the first line. It's called the 0th line because anything to the 0 power is 1. This is the first line. This is the second line. This is the third line. And it kind of makes sense. Like the third line is the one with the 3. The fourth line is the one with the 4. Come on with me there. Okay. I want you to set down your pencil and watch me do the first one, because if you look away, you will miss it. And it is just pattern finding. I'm going to try and use my colors here. Do you see how it's x plus 2 to the 4th? Yeah. You're going to use the 4th line. That's this one. This line right here. So pick a color, blue, pink, or green. That's what I've got here. Pink. Okay. Your coefficients come from that line. So look, I'm going to write this out. 1, 4, 6, 4, 1. That doesn't look pink at all, but that is the mark right. All right, we'll go blue next. Now you're going to go in descending order with whatever the first part is. So it's going to start out x to the 4th, and then this is x to the 3rd, x to the 2nd, x to the 1st, x to the nothing. And then I'm going to use green for the last one. I'm going to take the 2. It's going to go in ascending order, which means it goes up. So I'm going to start with 2 to the nothing, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. And in between all of them, I'm just going to put pluses. That is essentially the answer. We're just going to simplify some of it down. That's it. That's the shortcut. Like that's the answer. Go ahead and write it down. And if you want to use colors for each of those, you can. I usually write out the coefficients. And then whatever the first part is, it goes in descending order. Whatever the second part is, it goes in ascending order. And then we're just going to simplify it down. And then you just have the answer without having to do a whole lot of work. It's really just a pattern. I just wish the colors showed up better. When I take a picture and put it on Schoology, the colors will show up better, so you can always look at that. So we're just going to do like some cleanup. These are 2-step problems. One step is you write that all out. The second step, you just kind of clean it up a bit. This first term, do I need to write that 1? No. And anything to the 0 power is also 1. So how can I rewrite this first term just kind of like without all the garbage in there? Yeah, like it's just x to the 4th. Good. Plus, now order of operations, you have to do exponents first. So it's 2 to the 1st, just 2, times 4, 8. So 8x cubed Again, exponents first. Do you remember, please excuse my dear Aunt Sally? Do they still teach it though? PEMDAS? Okay. 2 squared, 4 times 6, 24. X squared. 2 cubed, please don't say 6. 8 times 4, 32x plus, now x to the nothing, that'll just be 1, so we're not going to write that. 2 to the 4th, 2 times 2 times 2 times 2. We overshot it a little bit. That'll just be 16, but this is your answer without having to do a whole bunch of other work. Thank you. And if you were like, hey, I didn't quite get that, I'm going to do a couple more examples. Just watch. Again, if you just want to set down your pencil and watch while I do this, and then I'll give you a minute to write it down. Do you see how it's to the third? That's the first thing you want to look for. Do you see that? We're going to use the third line, which is the one with the 3's in it. It's right there. 1, 3, 3, 1. Follow me? And with me on the thought journey. So I'm going to write down 1, 3, 3, 1. I wrote it in pink. You can't really tell, but whatever. You're going to take whatever's first, and it's going to go in descending order. So do you see how that's x to the third? It'll be x to the third. What's the next one? X to the second, x to the first, x to the nothing. Then you take whatever the second thing is. Now this one's a -4. Negatives are hard, okay? But you're going to take that -4. Oh, this was green. Hold on. You're going to take that -4, and it's going to go in ascending order. So it's going to start with -4 to the nothing, and then this one will be -4 to the first, -4 to the second, -4 to the third, and then you just slap a whole bunch of plus signs in between all of these. Sorry, that 3 wasn't very good there. Essentially, that's the answer. Don't slow down on me. You gotta know how to do this. That's the answer. We're just gonna clean it up a little bit. That's all. So how can I rewrite that first term without all the like mess in it? It'll just be x cubed. Because anything to the 0, sometimes I'll tell people to just scratch those out. Like anything to the 0 is gonna just be gone. Like you can just scribble those out if you want to. We do exponents first. So look at -4 to the first. -4, good. Times 3, good. So -12x squared. -4 squared would be +16, good. Times 3, 48x, perfect. And then -4 cubed, good, -64. And that is your answer. Exactly. This one's to the third. Hey guys, what are the coefficients going to be? Since it's to the third. 1, 3, 3, 1. You're going to be okay. I have to do a few more examples. Do you see how they're all kind of a little bit different? Like I can't, like I have to do like an example of each kind of thing that can happen. All right, and then you're going to take whatever the first thing is. In this case, it's a 3x, and it will go in descending order. So this will be 3x to the third, and then 3x to the second, and then 3x to the first, and then 3x to the nothing. And then the 4 is going to go in ascending order. So it'll be 4 to the, where do we start? 0, good. And then 4 to the 1, 4 to the 2, 4 to the 3, slap some plus signs in between. And essentially, that's the answer. That is the answer. We're just going to like make it look great. And again, anything that's to the 0, you can really scribble out. Like to the 0 is going to just be 1. If you don't like those, just get rid of them. If those like bother you, just scribble them out. Now this one had a 3 in it. It's going to be a little bit tougher. All right. You have to cube the 3 and the x. So 3 cubed, 27, x cubed, good. Now this is hard. I would maybe write like a little note to self above it. All right. You've got this 3. right? Then you've got 3 squared, which would be 9. And then you've got 4 to the first, which would be 4. So you've got this 3, you've got 3 squared, which is 9. You've got 4 to the first would be 4. What would that be? 3 times 4 is 12. Times 9, 108. If you're like, that was hard, look, I'm going to do it again. You have this 3. Then you have 3 to the first, which would just be 3. And then you have 4 squared, 16. 3 times 3 is 9 times 16. You know what? I don't know what that is off the top of my head. I'm going to multiply it out over here. Oh, what is that? 144? Oh, wait, that's not x cubed at all. It should be x. Just x. Okay. You'll catch that if you're paying attention, because like, do you see how I looked at it? I was like, wait, that's wrong. 3, 2, 1. Okay, and then this last one is just 4 cubed, 64. I'm Miss Cole. Close though. No, you can't simplify that any further because none of these are like terms. So you're just done. All right, hey guys, this one's to the 4th. So what are our coefficients going to be if it's to the 4th? Good, 14641. Just go ahead and write it. You're going to be okay. I really promise. I can't just do like a couple of these and be like, see ya. You have to practice it. It's pattern forming. You're going to be okay. I get everybody through it every year. All right, and then it would be 2x to the 4th, 2x to the 3rd, 2x to the 2nd, 2x to the 1st, 2x to the nothing. Some people don't even like to write the ones that are to the 0. That's personal preference. I put them because it's part of the pattern. If you just don't even want to write it, that's totally fine too. It's like up to you because it's going to go away. And then the second part is -1. So it's -1 to the nothing, -1 to the first, -1 to the second. I'm going to be quiet because I don't want to like just annoy you, but -1 to each of those, slap some plus signs in between. That's the answer. And to be perfectly honest with you, on a quiz or test, if you stop there, I only make it worth a point to simplify it down. So if you're like, oh, I shouldn't have put this in the recording, but if you're honestly like, I just don't feel like it, you will only lose a point because that's the answer. Do you get what I'm saying? Like that is the answer. We're just going to kind of clean it up. If you want to scribble out the stuff that's to the 0, you can do that because that's going to go away. First part, 2 to the 4th. 2 times 2 times 2 times 2. 16x to the 4th. And again, when you have a bunch of them like this, I would write it out. So we have 4. The next part is 2 to the 3rd. 2, please don't say 6. 2 to the 3rd. 8, good. And then -1 to the first is -1. So if you want to write it out, 4 times 8 is 32 times -1, -32 x cubed. And then this one would be 6 times 4, good, times -1 squared is 1. So that would be 24x squared. And then this one would be 4 times what? 2 times -1. Good. That would be -6x. And then how about this one? -1 to the 4th. Oh, I'm sorry. Thank you. Oh my gosh. I'm not even going to blame that on the morning. I just messed up. But do you see how it happens? Like, because you guys are really hard on yourselves about that, but like, it just happens. I added instead of multiplied. But you guys were looking after me. Appreciate you so much. All right, and then -1 to the 4th is just 1. I know, you are so smart. I always have to like tell people that. We'll try one more. You can do it. I really promise. Ooh, I made this one to the 5th. What are our coefficients going to be if it's to the 5th? 1, 5, 10, 10, 5, 1. You got it. You got this. Oh my gosh, you're all brilliant. I've told you this before. I love teaching pre-calc because, and usually right around now, everybody kind of finds their sea legs, and then it's like beautiful to watch everybody sort of like gain confidence, you know? All All right, so what goes first here? 2x to the fifth, good. And then 2x to the fourth. And then 2x to the third. And I'm going to be quiet because that's annoying. I know, I'm sorry. I feel really bad about that, but you need to be able to put it in a binder, so. And then the other part is y. So how do we start with the first one here? Y to the 0, y to the 1, y to the 2, et cetera, et cetera. And then slap some plus signs in between them. This is one of those things that like looks super intimidating like that, but what we're doing is like counting 1, 2, 3, 4, 5. This is like one of those lessons. If your parents ask you what you did at school today, you can just pull this out and they probably won't ask you anything else. Now, if you want to scribble out the stuff that's to the 0, you can do that. The stuff that's to the 0 is going to go away. All right, first one, 2 to the 5th. Okay, I would count on our fingers at that point. It would be 2, 4, 8, 16, 32. 32, x to the 5th. All right, now this would be 5 times 16. You guys have got that. 2 to the 4th would be 16, and then y is just y, so we don't have to worry about that. 5 times 16, well, 6 times 5 is 30. Is that 80? X to the 4th, y. Y to the 1 is just y. All right, plus, this would be 10 times 2 to the 3rd is 8. So again, that'd be 80 x cubed, y squared. Plus, this would be 10 times 4. So it will be 40 x squared, y to the 3rd. Plus, what's the next one? 10 x, y to the 4th plus, what? Yeah, the last one is just y to the 5th, right? Now, you guys got through all this with me. I'm just going to verbally say this. When we flip back to this one, and I'm going to write it up here so that if you want to check, you can. But if I asked you, because here's where it comes into play. If I asked you to do this with a multiplicity of 5, you would come over here and you would find your coefficients. They would be these ones. And then you would list it all out, okay? I'm going to write the answer and take a picture so it'll be up there if you want to, but it's just another example of something like this.